Okay, today we are going to learn how to find the amount of excess reactant that's left at the end of a chemical reaction. So we talked about the excess reactant yesterday a little bit when we were learning about the limiting reactant. So just as a quick recap, the limiting reactant is the reactant that runs out first, so it gets completely used up or completely reacted. Once it's completely reacted, the reaction stops. Okay, so when that happens, one reactant's gone, the other reactant, there's a little bit of it left over. So that one's called the excess reactant. So we're actually going to figure out how much of that excess reactant is left behind once the reaction's done. So how much of it could you actually find in, say, your beaker or test tube afterwards? So we're going to work from the example that we did yesterday, which was, we did two, but this one here is the one we're going to use. So we have already determined the limiting reactant. So we did that, just as a quick recap, by testing out each of the reactants. So we had 15 grams of potassium and 15 grams of iodine, and we wanted to find out which one of those two will run out first, therefore producing the least amount of product. So when we converted from grams of each reactant to grams of the product, in this case there was only the one product, we found that it was actually iodine that produced the least amount of reactant, and it was significantly less than what potassium produced. So we did all of this based off this balanced chemical reaction here. So we're now going to carry on and find out, okay, if this limiting reactant produces this amount of product, how much potassium is left over after the reaction has taken place. So let's just rewrite the balanced reaction just so that we have it in front of us. So we had potassium plus iodine produces potassium iodide, and then we balanced it like that. Okay, so remember we had 15 grams of each reactant. So we had 15 grams of potassium, and we had 15 grams of iodine. And we said this guy here was our limiting reactant. That means potassium's in excess. Okay, so how we do this is we say if all 15 grams of this iodine react, which we know it does because it's the limiting one, we can use that 15 grams to determine how much potassium is required to make all 15 grams of iodine react. So what we would do is we would take our limiting reactant, in this case iodine, so that the amount given in the original question, and we want to figure out how much potassium is required to react with that 15 grams. Okay, so what I'm going to do is I am going to switch over from grams of iodine to moles of iodine. And to do that, I use the molar mass. The molar mass was 253.8 for iodine. So that gets me into moles of iodine. And then I want to switch from moles of iodine over to moles of potassium. Okay, so I'm interested in potassium right now because it's my excess reactant. So how much of this potassium actually reacted with the iodine? So I'll use the mole ratio 2 to 1. And then finally, I'm going to go to grams. Okay, so moles of potassium on the bottom, grams of potassium on the top, and the molar mass of potassium is 39.1. Okay, so if I divide by 253.8, multiply by 2, and then multiply by 39.1, I get 4.62 grams of potassium. So what does that 4.62 grams tell me? It doesn't tell me how much potassium is left over. What it tells me is how much potassium was used. So this is the amount used in the reaction. Okay, so in order for all of the iodine, all 15 grams to react, this is how much potassium was required. Okay, so for whatever reason, we added 15 grams of potassium initially. but only 4.62 was used. So if we want to find out the amount of excess, which is the amount left over at the end, we take our original amount of potassium, we subtract the amount that was actually used in the reaction, and what's left over, 10.38 grams of potassium, tells us how much excess we have. Okay, so we added way too much potassium, and we kind of predicted that because we looked at the fact that when we determined the limiting reactant, I'm just going to switch over back to the original example again, we saw that iodine was producing way, way less potassium iodide than potassium was. So when you see that big discrepancy there, that's a good indication that we have way too much of this one reactant. So there's going to be quite a bit of excess, and we did find that to be the case. So only 4.62 grams of the original 15 was used. So let's just, just so if you're looking back in your notes, you remember this. This is the given amount of excess reactant. That's always like in the original part of the question. And you subtract from that, this value here is the amount of excess reactant actually used. Okay, and that is determined by using your limiting reactant and converting to excess reactant. So really, if you understand what you're doing, you already have all the tools to do so. It does make a lot of sense as to how you would go about doing this. So just a quick recap on limiting reactants. You'll recognize a limiting reactant problem. Well, first of all, it'll say something about limiting reactants, but there's always more than one given amount. Whereas in all our other stoichiometry problems, you are just given one amount of one of the reactants or products. In a limiting reactant problem, you're told how much of each reactant you have. You're going to convert all the reactants to the same product. You can pick any one you like, but try to pick the one that's going to require the least amount of work for you. So look ahead in the question and see if it's asking you about one particular product. You might as well choose that one. But you wouldn't be wrong if you chose the other one. Just try to create less work for yourself. The lowest answer, so when you're converting both reactants to the same product, it's the lowest amount is what you're actually going to get out of the reactant. So that's kind of what the next part says. The reactant that gave you the lowest amount is the limiting reactant, right? Because it's the one that's going to run out first. The other reactant or reactants, you'll only ever work with two, is considered to be in excess. And what we just did to find the amount of excess, subtract the amount used from the given amount. And finally, if you have to find more than one product, be sure you're always doing, once you know the limiting reactant, you do all future calculations based off the limiting reactant, so the amount of limiting reactant. So you don't have to continually find the limiting reactant over and over again. So what I want you guys to do is now, yesterday you should have practiced finding the limiting reactant on that worksheet number 1. I'm just going to pull that up again. That does not look quite right. Let me scroll to it. So on that same sheet, sorry, this is probably a big blur. There, limiting reactant worksheet 1 or limiting reagent worksheet 1. So you would have done all of these now, hopefully, and the key has been posted, so hopefully you've been able to correct them. Now what I want you to do is for each one of these, questions, even though it's not written on here, determine, well, it actually is, but you can't really see it at the top. I want you to determine the amount of excess reactant. So for example, if propane was your limiting reactant, figure out how much excess oxygen there was afterwards, just like what we just did. And do that for each one of the, however many questions are here, 4, I think. 3. If you finish those 3, you can go on to limiting reagent worksheet 2, and you can start working on a few questions on that sheet as well. I will also post that key. These are time-consuming questions. They're a lot of work, but practice makes perfect, just like everything we do in chemistry. So the more of these you practice, the easier you'll find them. All right, that's all for today.